All right, so today you're gonna have a little intro into graphing logs, and we will continue with graphing logs on Monday. So the important piece here to remember is that log and exponential functions are inverse functions of one another. So I already have graphed here y equals 3 to the x because that's something we already know. And the inverse function of y equals 3 to the x is y equals log base 3 of x. So notice how the bases are the same. The base of the exponential function is 3. The base of the log function is 3. So those are inverse functions of one another. If we use what we know about the graphs of inverse functions, one, that they're symmetric over the line y equals x, and to plot those points, remember we just flip-flop the position of x and y. So notice the main point on 3 to the x is 0, 1, right? So on our log base 3 of x, our main point is going to be 1, 0. This point is on every single parent log function, just like 0, 1 is on every single parent log function. 1, 0, and then because it's base 3, instead of being 1, 3, it'll be 3, comma 1. And that's your second main point. That will be your base, comma 1. So in this case, it's 3, comma 1. Okay? When we reflect our y equals 3x over this line y equals 3 to the x over the line y equals x, the graph itself reflects over, but also the horizontal line y equals 0, which is your asymptote, and it becomes a vertical asymptote. Okay, so with a log function, instead of having a horizontal asymptote like you do with exponential growth, you're going to have a vertical asymptote of x equals 0. Now, all the transformations apply here. If we shift up and down, we add to our y values. If we shift left and right, we add or subtract to our x values. Shifting left or right will be the only thing that'll change your vertical asymptote. Okay, now if you look at your domain and range of your exponential growth, negative infinity to positive infinity, your range, remember, was where we had the restrictions. So when we look at the log function, the x and y's flip. Therefore, our domain and range flip. 0 to infinity for domain, our range is negative infinity to positive infinity. Again, what will change the domain is if you have a shift left or right, okay, horizontally. If we change this to be log base 10, this point right here would be the point that changes, right? That's always your base, comma 1. 1, comma 0, always there. Base, comma 1 is your other important point. All right, let's look at the graph of y equals ln of x, okay? We talked about this briefly yesterday, what ln of x is. What it means log base e of x. We never write it as log base e of x. We write it as ln of x. It's the natural log function. Okay. When we graph this, first main point's the same, 1, comma 0, just like with log base 3 of x. Our next point is base, comma 1. Your base is e, which is about 2.718, right? So I'll go a little bit between 2 and 3, closer to 3, and that's your other point, and I will label it e, comma 1. I'll connect this. I'll draw in my vertical asymptote, and that's your parent log function for the natural log. Okay, you can see your domain. It doesn't go past the vertical asymptote, so your smallest x is 0. Your range, though, goes from all the way down from negative infinity to positive infinity. Okay, we'll do one graph with transformations, and then that'll be it. Okay, so if we look at this, we have log base 10 of x plus 3 minus 1. Let's first start talking about our parent function. Your parent function is y equals log base 10 of x, okay? Your 2 points, always 1 comma 0 and your base comma 1, okay? What we're going to do is we're going to do transformations to those 2 points. If you're wondering where do those points come from, go back to that first graph where we compared it to the exponential function. If you need to compare it to 10 to the x, you can, and flip-flop your ordered pairs, okay? All right, so let's go ahead and think about what's happening here. This right here, we're shifting left 3. This right here, we're shifting down 1. The other piece on your parent function is your vertical asymptote is x equals 0, because shifting left will affect that. So we can even start with that. Our vertical asymptote starts at x equals 0, which is your y-axis. We need to shift that 3 to the left. So that's your new vertical asymptote. Now the point 1, 0, which is typically right there, we need to shift that 3 to the left, down 1. So I'm going to count 1, 2, 3, down 1, and now that's here at -2, -1. So those are our one of our new points. And then your other one is typically at 10, comma 1. I'm off my screen here. But if I count from 10, comma 1, and I go left, I'm at 7, and then I go down, I'm at 0. So I move my x value 3 to the left and my y value 1 down. And then I connect my points. And it is a curve. And if you look at this, your domain, the farthest it goes to the left now is -3. It does not touch it. Farthest down is -infinity, and then they both go to +infinity.